All right. Hey, everyone. I've been here yesterday talking about dynamic data and capabilities. And for you guys that don't know about PeerStar is like our playground in terms of implementing stuff that we have been researching on dynamic data. And we implement and test stuff in PeerStar. And our goal, our mission, is to have a quick and easy way for app developers to start using IPFS for dynamic data. This is our main goal. And to do that, we need to offer some common primitives to build those apps. I have here 4 of them, but in the future we plan to add more. The first one is CRDTs, of course. As well, we need somewhat a form of identity and authentication. We also need a permission layer to validate like write access and read access and so on. And also, somewhat related to RBTB, we need some way to associate personal and app-wide storage layer. So another important goal for PeerStar is to provide app-wide and collaboration-wide gossip that is efficient and is performant and is scalable. And this is very difficult to accomplish, but we have been working on this, and we have just released a library called PeerStar App, which is on this repo. You can check it out right now. The current state of this library is that, of course, it provides collaboration using Delta CRDTs that I've spoken yesterday. It uses a custom topology, which is coined by the name of David Diaz, which is Diaz Peer Set, because the idea was mainly made by him, essentially. I think it's a great name, actually. So instead of like using the direct layer of discoverability of IPFS, we hook into the IPFS and build somewhat what we call a hash ring, which is, and we only connect to a subset of peers that are interested in in app collaboration and specific collaborations within the app itself. Additionally, the replication protocol has 2 modes of operation, which is the eager mode and the lazy mode, which accomplishes a better efficiency in terms of replication. All of this is explained in detail in this link below, in the Markdown. You can check it out. There's all the details there. And let's praise to the demo to see if all goes okay. So Pedro Teixeira made this example app, which have an application, and any of these things are collaborations. For instance, there is specific collaboration for a counter, a specific collaboration for an array, a text, like simple text input, and a discussion tree. I will explain that afterwards. Let's see if it works. So I will spawn here an incognito tab on the right. So these are 2 different peers. I already have here the number of app-wide peer counts on the left and on the right. They are both connected. So if I increment the counter here, it should increment on the right. Yeah, it works. The same thing for arrays. Thank you. Don't be too enthusiastic because it might fail. But array like CRDTs. It works as well. I can add some values here. It should propagate on the left, as well as a text input. But the most important one is the discussion tree. So I'm building a decentralized application, which is essentially a discussion. It's called Discussify. It's an application where you're able to discuss links, links, basically. You go there, and you can create a comment, and people can reply, people can delete comments, edit comments, and so on. And this will be being using a CRDT for this, and this is a custom CRDT for that purpose. I will try to emulate this and see if it works. So let's say that each comment has its own CID. For instance, CID A. it's a root comment, doesn't have a parent CID, and I will just put something here, just for the sake of the demo. So we have one comment. I can add another one. Oops, sorry. I can add another one, B. Doesn't matter. Okay. And now on the right, I will reference the first comment, saying that the child, the parent comment is the first one. I will add 3 here. Ba, 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 ba. And if, okay, it didn't work out for some reason. Oh, it's A, sorry, yeah. Okay, it's A. No, please work. No, it didn't work. Parent ID, yeah, parent ID, right. Whatever. No, it didn't work. It was supposed to be like in this entry, a children object of the child comments, like the replies of that comment. Okay, back to the slides quickly. The next steps for this library is to have identity built in, which is somewhat related to the talk I gave yesterday. We also need to have authentication and ownership about the operations on the CRDTs. We also need to have to integrate authorization and permissions, because that's a very requested feature, of course. Also, we need to provide encryption in storage, basically, encrypt everything. And also we need to do some load testing to ensure that this new topology is efficient and this new way of doing things is efficient, especially the Delta CRDTs and this new topology. And that's all. You might look into my slides over here. Yeah, thank you. I've messed it out with the children, probably. Yeah.
So are you communicating over WebRTC? So how are the two peers connected?
How the peers are connected. So as I tried to explain, we are wrapping the IPFS discoverability layer. So instead of considering all the peers being discovered through the layer, we question the peers that are interested in the app pub sub, and actually also for each collaboration within an app, because you might have like a chat room or different chat rooms. That's different collaborations between the app. And then we build an hash ring for the peers interested in these specific collaborations. And then we connect to the successor, the next peer. And then like 1/5 of the hash ring will also connect to it, and so on. And we build a consistent hash ring of a subset of peers. We're not connecting to all the peers, just a subset.
So you're doing, but how do you do discovery? Are you using a star signaling server, or
are
you doing a star signaling server for discovery of those peers in order to then actually go over pub sub?
We're using the rendezvous protocol to actually peers to be able to meet.
And what is rendezvous? Is that?
Rendezvous, yeah.
Yeah. Can you describe what that is? I don't know.
Yeah.
Okay, so, and it's dynamic peer-to-peer discovery, or is it, you still need a centralized star signaling? You have to bootstrap it?